An MCP memory server is a small program that does two things. It offers a model a few tools over the Model Context Protocol, and it keeps what it is told on disk after the conversation ends, so the same facts can come back later. Now, who is telling you? We build and sell a memory layer for AI agents that connects over MCP, so we are a vendor in the category this video explains. Nothing of ours is on screen. Every example is the public reference memory server and the specification. One promise: by Chapter 7, you will know exactly what a memory server puts in front of a model. The memory does not arrive as memory, it arrives as tokens. The specification says MCP provides a standardized way to share contextual information with language models and expose tools. A way to connect, not a capability. A server offers three things: resources, prompts, tools, no memory primitive. Here is a check you can run. The TypeScript schema is the protocol's source of truth. Search it for the word memory. It turns up once, in a comment about a boolean hint saying a web search tool reaches into an open world and a memory tool does not. Search for persistence, storage, retrieval, or vector, and nothing. Search for session, and nothing. That last one is new. Older revisions called MCP a stateful session protocol. This one opens by saying MCP is a stateless protocol, every request self-contained, and the tools page puts it flatly. MCP has no protocol-level session. It does let a client cache the list of tools, a directory listing, not anything you said. So, the honest sentence: MCP standardizes how a client discovers a tool, how it calls it, and what shape the answer comes back in. What gets stored and what comes back is the server's own design outside the protocol. There is no handshake anymore. The specification says exactly that. There is no negotiation handshake. Every request carries its protocol version, and the server accepts or rejects each request independently. So a client can ask cold with tools /list, which supports pagination and caching. The specification lists 7 fields on a tool definition. The one to watch is the description because of who it is written for. The schema's own comment says the description can be used by clients to improve the LLM's understanding of available tools, and that it can be thought of like a hint to the model. Discovery is not a menu for your application to render. It is prompt text. Before a single memory has been read or written, there is a paragraph of English sitting there, written for a model to read. On the reference server, 9 tools, each with its own description. 2. Every tool a memory server has runs through tools/list and tools/call. Be exact about what that leaves out. The same server publishes its graph as a readable resource too, and reading a resource is not a tool call. But every tool goes through those two. The 9 names you just saw are not methods. They are strings. They ride inside the parameters of a tools/call in a field called name next to a bag of arguments. Names like create entities, search nodes, read graph are values in that field, not verbs the protocol knows anything about. Underneath it is plain JSON-RPC encoded as UTF-8. Over SDDO, the client launches the server as a subprocess, which leaves the interesting question: who decides to make the call? The decision is the models. The specification calls tools model-controlled and says the model can discover and invoke them automatically from its contextual understanding and the user's prompts. It adds that there should always be a human able to deny a call. One of the specification's design principles is that servers should not be able to read the whole conversation, nor see into other servers. Full conversation history stays with the host, so a memory server is not supposed to be able to hear you talk. It gets one call and its arguments. If something goes wrong, there are two channels. An unknown tool is a protocol error. A failure inside the tool goes in the result, with an error flag set to true. The schema says why. Otherwise, in its own words, the LLM would not be able to see that an error occurred and self-correct. A result is the channel that reaches the model. So the question is what a server decides to put in one. The protocol does not say. It defines no relevance model, no ordering rule for results, and no opinion about what a good answer is. Every server invents this part. The reference server does this. It search lowercases your query, then checks whether that string turns up in an entity's name, its type, or its observations. A substring test. Their own comment sits above it. Very basic search function. No scoring, no ordering, no cap, no pagination. Results arrive in whatever order they sit on disk. And no timestamps, so nothing records when a fact was written or last used. This server cannot express recency or decay. The behavior everyone means by memory, deciding when to recall and what is worth saving, is not in the server. It registers no prompts. Those instructions live in its README as text you paste into your client. The server stores and returns. The remembering is done by the model, following text a human pasted. A tool result is a list of content blocks, and there are exactly 5 kinds. The one that matters here is text. Look at how the schema documents it. 1 line. Text provided to or from an LLM. That is the protocol's own description of the container your memory arrives in. On the reference server, every read does the same thing. It turns the whole graph into one JSON string and drops it into a text block. For backwards compatibility, the specification says a tool returning structured content should do exactly that. Then the client puts that string back into the conversation as a tool result block. In the Claude API, even its position is pinned immediately after the tool use block it answers. The other providers, we rename the container differently. And it lands where everything else lands. Anthropic's documentation says everything in the request counts toward the context window. It names the system prompt, your tool definitions, and every message, tool results included. The same page says the window gets worse as it fills. It names the effect context rot. As token count grows, accuracy and recall degrade. And that block is not neutral ground. Anthropic's guidance is to put untrusted third-party content in tool results and nowhere else, because Claude is trained to treat instructions inside a tool result with appropriate skepticism, and not to put your own instructions there. So the whole idea, your memory does not arrive as memory, it arrives as tokens. On Anthropic's stack they land in a block Claude is trained to read as data, not as instruction. They share one finite window with everything else in the request, and nothing in that block announces itself as memory. It is a tool result with an identifier and a string in it. One honest caveat. A provider can keep a result out of that window. Anthropic documents a mode where the model calls your tools from a code sandbox, and intermediate results are not loaded into the context window. Notice how much of that the protocol decided. None of it. MCP hands the client a content array and stops. Everything after that is the provider and the client. Wherever the server decides, because the protocol has no opinion. Its README calls the reference server a basic implementation of persistent memory using a local knowledge graph. On disk, that is one JSON object per line, entity, or relation. Search it for database or index, and you get nothing. Writing is one call. The server serializes the whole graph and overwrites the entire file every time anything changes. No append and no lock, so if two clients write to one file, the last write wins. And the file sits next to the compiled JavaScript, not in your home directory. Plain text, no encryption, no access control. That is not a complaint about a reference implementation doing its job. The protocol is silent on storage, so storage is a product decision. 3 honest cases. And remember, we sell a memory server. First, if nothing needs to survive the conversation, you do not need one. That is the entire function. Second, if the facts already fit in the window, putting them there is more reliable. On the reference server, nothing pushes memory into a conversation. It arrives when the model calls a tool or when the client reads the graph as a resource. And the model decides that from a description string and its reading of the conversation. Pasting a fact is a certainty. A tool call is a decision. Third, if what you want is a text file with 9 functions on it, the reference server is exactly that. Read it before you buy anything, including from us. What you should be shopping for is the part the protocol does not specify. What gets admitted? What comes back for a given question, and in what order? What happens when 2 clients write at once? Because however that gets answered, what comes back is still tokens in one window.